There are other types of correlation coefficients that you could use that are all deviations off of the Pearson correlation coefficient, which is labeled as R. The Spearman's Rho coefficient describes the correlation between the ranked or ordinal data. You'll substitute the numerical ranks into the formula and solve for R. There's also the Point-Bisserl correlation coefficient. This describes the correlation between qualitative or nominal data. If there are categories, you want to assign the numbers to the categories, such as female or male. Female could be 1 and male could be 2, and you plug those into the equation and solve for R. Lastly, you have the Kramer's phi coefficient. This describes any qualitative variables. You'll assign ordered numerical codes and solve for R. You can use a computer output to also analyze large batches of data. This will help so you don't have to do everything by hand, which is easier when you're using a smaller batch. Some 3 widely used statistical programs are Minitab, SPS, which stands for Statistical Package for the Social Sciences, and SAS, which is Statistical Analysis System. A correlation matrix is a table showing correlations for all possible pairs of variables. Whenever there are 2 or more variables, the correlation matrices are useful for showing the correlations between all possible pairs of variables. The value of the sig helps interpret statistical significance of a correlation. This evaluates the observed value of R relative to the actual number of pairs of scores. The smaller the sig value on a scale of 0 to 1, the more likely that you will observe the correlation with the same sign, either positive or negative. Usually researchers focus on those that are less than 0.05 or 5% for being significant.